Next, the topic is V antenna. So, let us check what is a V antenna. An antenna in which the conductors are arranged in V shape. Here we can see a figure for the V antenna. Here we can see the conductors that are arranged in a V-shaped structure. There is a balanced feed at the apex. Here we can see a feed line. Two conductors are arranged in V shape and there is a balanced feed at the vertex. Here the feeding is balanced type, so we can say the balanced feed at the apex, and the included angle, the length and the elevation are chosen to obtain the desired directional properties. So the factors that should be considered while designing this V-shaped antenna were its length, elevation and the included angle, and the excitation to each wire that is out of phase, and the radiation pattern can be unidirectional or omnidirectional. It is easy to construct and inexpensive. By adjusting the included angle of V antenna, the directivity can be made greater. The directivity of the V antenna can be made higher by adjusting the included angle value. And the side lobes that should be smaller in case of V antenna, and the designs for maximum directivity usually require smaller included angles. So the condition for maximum directivity is smaller included angles for longer V's. Most V antennas are symmetrical, that is theta 1 is equal to theta 2 and L1 equal to L2 is equal to 1. Here we can see the theta 1 and theta 2, L1 and L2. So while the symmetrical case, theta 1 is equal to theta 2 is equal to theta naught value, and L1 and L2 that is equal to 1. This V antenna radiation pattern can be unidirectional or omnidirectional. Here we can see the V antenna in unidirectional pattern and its radiation pattern obtained here is shown. This is V antenna and its lobes. Here these are the arms of this V antenna. Here we can see a feed line and this is the transmission line, and there is a balanced feed we are providing at the feed line as already said. To achieve the unidirectional characteristics, the wires of V antenna must be non-resonant. That is, to obtain the unidirectional property, the wires of V antenna must be non-resonance, and this can be accomplished by minimizing or eliminating reflections from the ends of the wire. The reflected waves can be reduced by making the inclined wires of the V relatively thick. The reflections can be reduced or minimized by making the inclined wires of the V relatively thick. That is, these wires can be made thick, thereby we can reduce the reflection. Thereby we can reduce the reflections by making these wires thick. And the one way of terminating the V antenna, it will be attached to a load. Here we can see the termination of this V antenna can be done by attaching it to a load value, usually a resistor equal in value to the open end characteristics impedance of the V wire transmission line, and the resistor value that should be equal to the open end characteristic impedance value of the V wire transmission line. V wire transmission line characteristics impedance value, it should matches. So the V antenna, it's attached to a load, usually a resistor equally in value to the open end characteristics impedance of the V wire transmission line. The terminating resistance can also be divided in half, and each half is connected to the ground leading to the termination. Similarly, here the first case we can see the reflections. In order to reduce the reflections or eliminations by terminating the open ends, here in actual diagram we can see only the V structure. Here in the actual structure of V antenna, we can see only a V structure. In later case, now we see a diagram that is showing, see, it's terminated. These V ends are terminated. These V ends are terminated by a resistance load in order to reduce the reflection. So thereby we can say the reflected waves can be reduced by making the included wires relatively thick, and it's properly terminating the open ends of the V, leading to purely traveling wave antenna. By terminating the open ends of this V, leading to a purely traveling wave antenna, and one way of terminating V antenna, it will attach to a load, usually a resistor in equal in value to the open end characteristics impedance of the V-wave transmission line. The terminating resistance. This terminating resistance can also be divided in half. That is the case here. We can see this terminating resistance here we are given is divided in half, and each half is connected to ground. Usually the terminating resistance or the resistor that should be connected to at the open end is here, it's divided in half, and each half is connected to the ground, leading to the termination. Both the cases are same. And these patterns of these inudal wires, the patterns of inudal wires of the V antenna are conical in form, are inclined at an angle from their corresponding axis. The angle of inclination is determined by the length of each wire. Here, the angle of inclination is determined by the length of each wire. For the patterns of each leg of a symmetrical V antenna, to add in the direction of the line bisecting the angle of V and to form a one major lobe, the total included angle 2 theta naught of the V should be equal to 2 theta m, which is twice the angle that the cone of maximum radiation of each wire makes with its axis. When this is done, beams 2 and 3 of figure below are aligned and are constructively for unidirectional pattern. That is for the patterns of each leg of symmetrical V antenna. Here we can see the symmetrical V antenna, the patterns of each leg. Here in each side we can see 2 leg here and the other leg, that is 1, 2 on the one side. These 2 legs are on one direction, and then 3, 4 are in on the other wing. If for the patterns of each leg of symmetrical V antenna, to add in the direction of line bisecting the angle of V and to form a one major lobe, the total angle included angle 2 theta naught. This is the total included angle 2 theta naught of the V should be equal to 2 theta m value, which is twice the angle that the cone of maximum radiation of each wire makes with. This is one wire and this is the another wire. This 2 theta naught value of V, that should be equal to 2 theta m, which is twice the angle of the cone of maximum radiation. That means it is twice the angle that is making by the maximum radiation of each wire. When this done, the beams 2 and 3 of figure below are aligned and constructively. This is this 2 and 3 of this beam. The beams 2 and 3 or the leg 2 and 3 of figure, or the beams from these 2 and 3 legs are aligned and add constructively for unidirectional pattern. For optimum operation, typically the included angle is chosen to approximately theta naught is 0.8 theta m. When this is done, the reinforcement of the fields from the 2 legs of the V lead to total directivity for the V of approximately twice the directivity of one leg of V. For a symmetrical V antenna with legs each of length L, there is an optimum included angle which leads to largest directivity. For optimum operation, the included angle is approximately taken to 0.0 theta, 0.8 theta m value. When this is done, the reinforcement of the field from the 2 legs of the V lead to a total directivity for the V approximately twice the directivity of one leg of the V. That is, total reinforcement of the field of V antenna that should be equal to the directivity. Total directivity is approximately twice the directivity of one leg. That is total directivity that should be equal to the twice the directivity of one leg of V antenna or each leg of V antenna. For a symmetrical V antenna with legs each of length L, there is optimum included angle which leads to largest directivity. And the design data for optimum included angles of V dipoles were computed using moment method techniques and is given are. These are the equations for finding the maximum included angle, where the 2 theta naught is the included angle between the two wires of the V antenna, and the equation for finding this included angle value is minus 149.3 L by lambda cube plus 603.4 L by lambda square minus 809.5 L by lambda plus 443.6 if the L by lambda value ranges between 0.5 to 1.5, where we know where L is the length of the wire and lambda is the wavelength of the operations. Wavelength means the distance traveled by the wave or the distance covered by the wave for a particular frequency of operation. If the L by lambda value that ranges from 1.5 to 3, the equations for finding the maximum inclined angle will be 30.39 L by lambda square minus 78.27 L by lambda plus 169.77 for the ranges from 1.5 to 3. This is the equation for finding directivity. D naught is 2.94 L by lambda plus 1.15 for the ranges of 0.5 to 3. So these are the points comes under the case of this V antenna. So the points we have to consider is, what is a V antenna? The V antenna is an antenna in which the conductors that should be arranged in V shape. The conductors that should be arranged in V shape. The conductors that are arranged here, we can see a diagram for V antenna. That is the two conductors, two long wires that can be arranged in V shape, and there is a balanced width at the apex. The included angle, the length, elevation are chosen to obtain the desired properties. So the factors for designing will be its length, elevation and the included angle, and the excitation to each wire is out of phase, and the radiation pattern obtained is directional or omnidirectional. It is easy to construct and inexpensive. By adjusting the included angle of V antenna, the directivity can be made higher, and the radiation pattern is shown in this figure. And the next, to achieve unidirectional characteristics, the wires of V antenna must be non-resonance. Here we can see this is accomplished by minimizing or eliminating the reflections from the end of the wire. The reflected waves can be reduced by